This is a lesson over identifying types of chemical reactions that goes along with Unit 5. In this lesson, we're going to talk about 5 main types of chemical reactions. Combustion, which basically is burning. We'll abbreviate that with just the letter C. Synthesis, we're going to abbreviate with the letter S. Decomposition, we'll abbreviate with just the capital D. Single replacement, which will be SR, and double replacement, we'll abbreviate as DR. The first type we'll be looking at is called combustion. So what is combustion? Well, combustion is just another word for burning. Okay, so if something is burning, you see light, there's heat given off, odors, that kind of thing. So combustion, something that is visibly on fire. One of the things that has to be present for combustion to occur is oxygen. I don't know if you recall, but when you were in probably elementary school, you had Fire Safety Week, and they talked about the fire pyramid or the fire triangle. So you need 3 things to have a fire. One, you have to have some kind of fuel, so something to burn. You have to have oxygen present, and you have to have some kind of energy source, something to ignite it. If you have all three of those things, you have a fire. Take one away, you don't have one. And so one of the indicators of a combustion reaction is that you'll have something reacting with oxygen. In this model, you have some kind of hydrocarbon here, and then here's the oxygen molecule. So it's O2. You have 2 oxygen atoms there to bond with it. And a hydrocarbon is basically exactly what it sounds like. I mean, if you look at this word, you have the hydro part, that's hydrogen, and then you have carbon. And so in this case, it looks like we have 3 carbons and then hydrogens bonded to them. This is a hydrocarbon. This would be propane with 3 carbon atoms. You don't need to know that, but it is a hydrocarbon. When you have a combustion reaction, the products that are going to be produced from it are going to be water and carbon dioxide. And so here in this case, here's your water molecule. So you have your oxygen and 2 hydrogens attached to it. And then the other product is going to be carbon dioxide. And so in a combustion, these 3 parts are going to be the same. You're going to have oxygen as a reactant over here on the left side. And then on the right side, the products, water, carbon dioxide. So those are things that are going to be indicators you have a combustion reaction. And here we have an example of a combustion reaction. We have the combustion of methane. And so you'll notice here's the hydrocarbon, that's the methane, combining with oxygen, so these are the original reactants. And then they're producing carbon dioxide and water on the product side. So very indicative of a combustion reaction. So if it's not combustion, there are a couple of other ways that reactions can occur. We're going to look at decomposition, where essentially, think of the word decompose, something breaking down. So in a decomposition, one molecule is going to split into 2 or more, and it can be atoms or molecules, but essentially one thing breaking down into multiple parts. And then the other one is synthesis, where you have a molecule is going to be made from 2 or more atoms or molecules being combined. So it's the exact opposite. It's assembling or putting things together. Think back to your days as being biologists. Photosynthesis, where plants take carbon dioxide and water and assemble those molecules into simple sugars like glucose. That is a synthesis reaction. It's even in the name, photosynthesis. It's using light energy to assemble sugars. And so this is a little graphic representation of synthesis. So here, we have this dapper guy in his top hat and this lovely lady with her red bow, and they are 2 separate things, and then they change and they become together. They become a couple. So they are 2 things, 2 separate things, turning into one thing. That's an indicator you have a synthesis. So 2 or more things becoming one. Yep, synthesis. And for a generic form of this reaction, We've just got the symbols, so just A, B. These can be elements, they can be compounds, I don't care. But it's two separate things that turn into one. So this is definitely a compound, compound AB, and that's just a generic form of the equation. And here is an example of an actual synthesis reaction. We have sodium combining with chlorine. One thing you'll note, chlorine diatomic. Okay, and I've mentioned this to you before, but just as a little refresher, there are 7 elements that are never found alone. And these 7 elements are called the 7 diatomics. Couple of ways you can remember them. The way I like, go to 7, make a 7. And so you start there at nitrogen number 7 and you go across nitrogen, oxygen, fluorine, then down to chlorine, bromine, iodine. Then you have to remember to go up and get hydrogen, that goofy guy sitting up there off on its own. So those are the 7 diatomic elements, always found as molecules, so they always have a subscript 2 with them. Another way people remember them, Brinkelhoff. So you spell out Brinkelhoff, B-R-I-N-C-L-H-O-F. Same 7 elements, but just another way to look at it. But anyhow, sodium and diatomic chlorine combining and forming sodium chloride salt ionic compounds there, formula units. You'll notice we have this balance with the coefficients in front. There's your balance example of a synthesis reaction. And like I mentioned before, decomp is just the exact opposite. It's one thing breaking apart. So here's the happy couple. They're together. Something happens. Now they're separate, right? So there's the lady in the bow, guy with the top hat. They're no longer a couple. One substance breaks down into 2 or more separate things. So 1 becomes 2. Here's an example of something decomposing. I guess I forgot to put just the generic form. I guess if you really want to do the generic form, it would be like AB turns into A plus B. Or here's just a real-life example of something breaking down or decomposing. Here we have hydrogen peroxide, and it's breaking down into water and then oxygen. Notice it doesn't have to break down into 2 component elements. You can have a compound and an element, and just be aware there was one thing that turns into 2 separate things. That's indicative of a decomp. It can be elements, but it could be 2 compounds, it could be an element and compound, it could be whatever. It could be 3 things. It's just breaking down. Okay, so if it's not combustion, it's not decomp, it's not synthesis, how are some other ways that molecules can split and recombine? Well, there are 2 ways you can do this. If you have a molecule and one part of it is pushed out and replaced, and then kind of left on its own, they call that a single replacement reaction. And then there's one other one, so if you have 2 pairs of atoms forming molecules, they can split apart and switch partners. And in that case, it's called a double replacement reaction. And so here we have a representation of a single replacement. Here we have, okay, this couple. We have this guy in the top hat, gal in the bow, and then there's this lady in the brown dress, okay? All of a sudden, this guy catches her eye. He's going to dump this gal. She's gone. He's going to go with her. So essentially, the lady in the brown dress replaces the girl with the bow. The girl with the bow is out on her own. So here's the new couple. Here's the sad-faced girl. Okay, single replacement. One thing replaces the other thing out on its own. Basically, one element knocked another element out of that compound. This would be a generic form of this reaction. So if this is compound AB, and then we have just an element X over here, X is going to go in and take the place of B. B is off on its own. Okay, real life example of this. Here we have hydrochloric acid and zinc. Okay, so essentially the zinc is going to go in and take the place of hydrogen, and the hydrogen's kicked off. So zinc is entering the compound, this hydrogen is being kicked off. So you get two new products. You've got zinc chloride here and then hydrogen. So one thing enters the compound, kicks something else out. And here we have a double replacement reaction. So here's a couple. You got the guy with the top hat, the girl with the bow. Here you have the mustachioed man and the gal with the dress. All of a sudden, for whatever reason, they switch dance partners, all right? So the guy with the hat's going to go with the girl with the dress. The guy with the mustache is going to go with the gal with the bow. So one couple, it's going to go here, and it's going to go here. It's almost like an algebra, like when you FOIL. So you have two new couples that, I guess, are at the end. And like I just mentioned, two compounds switch ions with each other. And this would be a generic form of the reaction. AB plus XY yields AY plus XB. And so the cation of the first is going to go with the anion of the second. The cation of the second goes with the anion of the first. So just like in algebra, we're foiling. They're switching dance partners. This guy is going to go with that gal. This guy is going to go with that gal. AY, XB. And here is a representation of how that works with a real chemical equation. So we have barium chloride and sodium sulfate. And so the barium, the cation, is going to go with the anion of the second. So it turns into barium sulfate. Likewise, the cation of the second, the sodium, is going to go with the anion of the first, and it's going to make sodium chloride. Very indicative of a double replacement reaction. Two compounds are reactants. You have two new compounds as products. And those are the 5 main types of chemical reactions you're going to be looking at in this unit. Combustion, synthesis, decomp, single replacement, double replacement.